Hello everyone, welcome to another video on differential calculus. I am still looking at differentiation from first principles. My previous video I was looking at first principles, the origin, and a couple of definitions that I went through, and I promised that I would come again with another video to deal with first principles a little bit more. And now I have 5 questions here that I want to go through very quickly. So like I said, we're still on differentiation from first principles. The first question says differentiate the following functions from first principles. So we have a f of x equals 2x squared minus 5x plus pi. We're supposed to determine the derivative of that function using first principles, and then we'll move on to number b, c, and all the way up to e as quickly as I can manage. So let's look at the first one then. So the first one is our answers. This is our question for today. A, we have f of x is equal to 2x squared minus 5x plus pi. There you go, 2x squared minus 5x plus pi. So our solution starts as follows. So we're going to say, therefore, what is f of x plus h? And the answer is, wherever there is x, we have to place x plus h. So this will be 2 open brackets x plus h, and then we have to square that, minus 5. Where there is x, we have to place x plus h, and then pi is alone, there is no x there, so we just leave it the way it is. Expanding this, if you have watched my videos on algebra, I've explained how you expand this. Maybe let me just repeat it very quickly. You take x multiplied by itself, it is x squared. Take x multiplied by h, it is xh. Double this, and the sign there is plus, respect that, and then h times itself, it will be h squared. And then expanding that, it will be 5x minus 5h plus pi. Now, continuing this part here, we're going to get 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus pi. Now we're going to the formula, first principles formula for derivative. F prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting what we know, this is limit as h approaches 0 of what? This notation here, f of x plus h, must be replaced by that. So we have 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus pi minus, remember I told you last time that you must use brackets there. Without brackets you are going to have a problem. So I must have in that space 2x squared minus 5x plus pi. Space there, a bit of a problem, but we'll recover in the next step, all over h. Now expanding that, we have limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus pi minus, expanding that, remember that expression is this expression up here. So expanding that, we have 2x squared minus, obviously, and then this is going to be plus 5x and then minus pi all over h. Now cancelling what we need to cancel. Notice something that let me redraw this line here. All right, notice that this cancels that, and then 5x cancels that, and the pi cancels that. So what do I have in the numerator? Limit as h approaches 0 Let me clean up this a little bit over here. Right, limit as h approaches 0. In the numerator, what do I have? I have 4xh plus 2h squared, and then minus 5h over here, all over h. So we have 1, 2, 3 terms remaining in the numerator. Next, our common factor, if you remember from the previous lesson, the common factor must always be h in this case. Open brackets. H in there, it's 4x. H in there is plus 2h. H in there is minus 5, like so, all over h. And the h's cancel. What we have in our next step, limit as h approaches 0 of 4x plus 2h minus 5. And as h approaches 0, positive 2h approaches 0, and therefore our final answer is just going to be 4x, this one here, minus 5. That's our final solutions. This is the value of the derivative of this function here from first principles. All right, let's move on to question number B. As quickly as we may. I am repeating these concepts, and I believe strongly that repetition is key in the process of teaching and learning. Our second question is f of x is equal to ax squared plus bx plus c. So number B, what we have is f of x is equal to ax squared plus bx plus c, where f of x plus h is equal to a, where there is x, now we must put x plus h whole squared plus b, x plus h, and then plus c there at the end. Expanding this, a, we have x squared, if you remember, plus 2xh plus h squared, and then plus bx plus bh plus c. Expanding this part here, we have ax squared plus 2axh plus ah squared plus bx plus bh plus c. Right, let's go to the formula. Therefore, we know f prime of x is equal to the limit as h approaches 0 of what? Of f of x plus h minus f of x all over h. Substituting the expression, we know, let me stretch back a little bit, limit as h approaches 0 of this expression. Now it must come into that space, ax squared plus 2axh plus ah squared plus bx plus bh plus c minus, open brackets, ax squared plus bx plus c all over h. Please guard against leaving a huge amount of space between limit expression here and the first term in the numerator there. Look at where the division line is starting from. Don't leave too much space between this expression here and that part. All right, so we're moving on to the next part is limit. Limit. Let me remove some of the part here. This must go. Right. Limit as h approaches 0 of what? Of ax squared plus 2axh plus ah squared plus bx plus bh plus c minus ax squared minus bx minus c all over h. Let's cancel what we can cancel. Notice something here, ax squared cancels ax squared there. Bx, there's your bx, cancels that one there, and there's your c, cancels that one there. In the numerator, what do we have? We have here we have limit as h approaches 0 of 2axh, that part, and then plus ah squared, that part, and then finally we have plus bh, that term there, all over h. Factorizing the numerator, common factor is h. Limit as h approaches 0 of h, open brackets, 2ax there, the h is gone. We have 2ax plus ah, and then plus, if you notice, if you take out h here, you're going to be left with b. And then we say all over h. And the h is cancelled. What is our next step? Limit as h approaches 0 of 2ax plus ah, not ab, ah, and then plus b, like so. Now, as h approaches 0, ah will approach 0, and our final answer is going to be 2ax plus b. This is our final expression for the derivative of ax squared, the derivative of ax squared plus bx plus c with respect to x. Remember, we are treating a, b, and c as constants. Right, let's move on to our number c. Number c is g of x is equal to 5x squared minus 3x. Right, now we're no longer dealing with f, we're dealing with g now. Right, so number c, we are now saying g of x is equal to 5x squared and then minus 3x. That's our g of x. Now, what do we do next? Well, what we do next is to say, therefore, g of x plus h is equal to 5x plus h. We square that minus 3x plus h. Doing the same process, this is 5. There you have x squared plus 2xh plus h squared minus 3x. Remember the minus sign here? Minus 3x times x is minus 3x. Minus 3 times h is minus 3h. Please be careful of the minus sign there. Expanding this, we get 5x squared plus 10xh plus 5h squared minus 3x minus 3h. Going into our formula, now we have g. So we're going to say, therefore, g prime of x is going to be limit as h approaches 0 of g of x plus h minus g of x all over h. Remember not to use f because here our function is g. Right, substituting the expression, moving back a little bit, we have limit as h approaches 0 of what? Of 5x squared plus 10xh plus 5h squared minus 3x minus 3h, and then minus brackets there. You must never leave out these brackets here. So that is 5x squared minus 3x in that space. It will be, remember, g of x is 5x squared minus 3x. It must come into that space there with brackets all over h. Now, simplifying the numerator, we have limit as h approaches 0 of 5x squared plus 10xh plus 5h squared minus 3x minus 3h minus 5x squared plus 3x all over h. Now, in the numerator, if we cancel, this cancels that, and then 3x cancels that. And so what do we have? We have limit as h approaches 0 of 10xh, that term, and then our next term is 5 plus 5h squared, and then our final term is minus 3h. There it is, all over h. Factorizing the numerator, we change the pen here. Factorizing the numerator, what do we have? We have limit as h approaches 0 of the common factor is h, and then we have 10x plus 5h minus 3 all over h. The h's cancel. What do we have? We have limit as h approaches 0 of 10x plus 5h minus 3. Now, as h approaches 0, 5h will also approach 0, and therefore our final answer is 10x minus 3. That's our final answer, 10x minus 3. So in other words, the derivative of that with respect to x is 10x minus 3. And that's the gradient of a tangent to that function there, g, at any point. Substituting x with a 1, it will give you 7, which means at x equals 1, the gradient of a tangent to this function is equal to 7. Right, let's move on to number D. Number D, we have 4x squared minus 1. G of x equals 4x squared minus 1. So number D, G of x is equal to 4x squared minus 1. Now, the same procedure. Therefore, G of x plus h, G of x plus h is going to be equal to, where there's x, place x plus h. 4x plus h all squared, and there's no x on 1 there, leave it the way it is. Expanding that, like we've explained in the previous questions, this will be x squared plus 2xh plus h squared, and then minus 1. Expanding that, we get 4x squared plus 8xh plus 4h squared minus 1. Going into the formula, therefore we know that g prime of x is equal to limit as h approaches 0 of g of x plus h minus g of x all over h. Substituting that expression into that space there, we have limit as h approaches 0 of 4x squared plus 8xh plus 4h squared minus 1, and then minus, open brackets. In the place of g of x, we place 4x squared minus 1, like so, all over h. Removing those brackets there, we have limit as h approaches 0 of 4x squared plus 8xh plus 4h squared minus 1 minus 4x squared. Remember now, minus times minus is plus. So we have plus 1 all over h. Let's cancel what we can cancel. The 4x squared cancels that one there. The positive 1 cancels the minus 1 there. And so what we have now is limit as h approaches 0 of 8xh plus 4h squared all over h. Common factor in the numerator is going to be h. So limit as h approaches 0 of h, 8x plus 4h all over h. The h's cancel. We have limit as h approaches 0 of 8x plus 4h. As h approaches 0, 4x plus h, as h approaches 0, 4h will approach 0 as well. So the whole expression there will simplify to simply 8x. So 8x is the derivative of that function there with respect to x. Right, this is how you go about it using first principles. Finally, our number E, we have m of x is equal to 2x minus x cubed. So number E, m of x is equal to 2x minus x cubed. Now, I want to explain how you handle the x cubed shortly. Therefore, we're saying, therefore, m of x plus h is equal to 2x plus h minus x plus h cubed. Now, this part here requires me to explain it by using what we call Pascal's triangle. So, Pascal's triangle basically says Let me get a fresh page here. Pascal's triangle basically says if you have a plus b all to the power 3, perhaps this is a bit far. Let's say we have a plus b to the power 0. We know that the answer is 1. A plus b to the power 1. We know the answer is a plus b. So I'm going to say 1a plus 1b. Keep an eye on the coefficients. We have a plus b. I've explained to you now. If you say power 2, this will be a squared plus 2ab plus b squared. Now notice the coefficients here, 1, 2, 1. Now, Pascal's triangle, basically, if you look at it from here, we basically have something like this here. Our first value there is going to be 1, and then we have 1, 1. So here the power will be 0. There the power will be 1. We have 1. I add these two up, I get 2, and then I have 1. That will be power 2. So therefore, for power 3, what we are expecting to get is actually 1, the leading one. We add these two up, we get 3. We add these two up, we get 3, and then 1. That means these are our coefficients. And the powers, remember here, the power of A is decreasing. There is a 2, there is a 1 here, and here there's a power 0. So it's decreasing 2, 1, 0. Powers of B, if you like, this is B power 0. The powers of B are increasing 0, 1, and here 2. In other words, when I add these two powers, I must always get the 2 there. 1 plus 1 is 2, 2 plus 0 is 2. So therefore, for A plus B cubed, what I'm expecting to get will be, watch this out, coefficient 1 there, coefficient 3, and coefficient 1. Let's start with A. A has a power of 3. B must have a power of 0. There's a plus sign because it's plus all through here. And then A, the power of A must decrease, so I must have A squared now. The power of B will increase by 1. And then plus. Here, the power of A would decrease to 1. Power of B must increase to 2. Plus. Here, the power of B, of A, remember, 3, 2, 1. So the power of A here must be 0, but the power of B must increase from 0, 1, 2, 3. So the expression then is A cubed plus 3A squared B plus 3A B squared, and then plus B cubed. Well, if you're not happy with this, we can go the traditional approach. The traditional approach, which I'm going to do very quickly for the sake of time, because we are restricted in terms of time. The traditional approach would be A plus B cubed is the same as A plus B multiplied by A plus B multiplied by A plus B. That's the traditional approach. So this is A plus B. And what is this? This is A plus B all squared. Have we explained this? Yes, we know that this is A plus B. And then this one here is just what we explained in the previous cases. A squared plus 2AB plus B squared. Expanding here, I have to take A across and then B from there up to there, up to there. So A times A squared is A cubed. Plus A times 2AB is 2A squared B. A times B squared, it is AB squared, right? B times A squared is A squared B. B times A at 2AB is 2A B squared. B times B, it will be B times B squared, it will be B cubed plus B cubed. Now, let's put like terms together. This one and this one are like terms, and those two are like terms. So what do we have? A cubed plus 2A squared B plus A squared B. This part here, remember these two are like terms. It's going to be 3A squared B plus AB squared plus 2AB squared is going to be 3AB squared. And then finally B cubed. This is exactly what we got by using Pascal's triangle. So Pascal's triangle actually can help you. There it is. It can help you expand even up to fourth power, fifth power, whatever power you have. But if it goes beyond that, it's going to be useful for us to use what we call binomial theorem, which I'm going to explain when we're looking at how to use prove the power rule. But let's continue with our question just to quickly go through this. So our question number 3 then is gonna be, I've started it. Let me just quickly get my page. So we are talking now about number C. Too many pages here. All right, I think it's down here. All right, there it is. Right, let's move quickly on. So this is going to be 2x plus 2h minus, if you remember this one here, I said this is x cubed plus 3x squared h plus 3xh squared, and finally plus h cubed. Expanding that, we get 2x plus 2h minus x cubed minus 3x squared h minus 3xh squared, and then minus h cubed. Going to our formula for first principles, we're going to say, therefore, we know our m prime of x is equal to limit as h approaches 0 of m of x plus h minus m of x all over h. Remember, it's not very easy to change from f to m or g or whatever function it is. You need to slow down a little bit. I'm a bit fast here because of time. So let's substitute then. So what we have now here, we have limit as h approaches 0. This expression here, it will be 2x plus 2h minus x cubed minus 3x squared h minus 3xh squared minus h cubed minus open brackets. We have 2x minus x cubed all over h. Expanding that part there, we have limit as h approaches 0 of 2x plus 2h minus x cubed minus 3x squared h minus 3x h squared minus h cubed minus 2x plus x cubed all over h. Let's cancel what we can cancel. The h cubed cancels that one there, and then the minus 2x will cancel that part there. So what do we have now? We have limit as h approaches 0 of 2h, that part or that term, minus 3x squared h, that term, and then minus 3h h squared, that term, and finally minus h cubed all over h. Factorizing the numerator, we have limit as h approaches 0 of h 2 minus 3x squared minus 3xh minus h squared all over h. Cancelling this, we have limit as h approaches 0 of what? Of 2 minus 3x squared minus 3xh minus h squared. That's what we have. As h approaches 0, these two terms will approach 0, the two of them. And so my final answer, therefore, will be what is remaining, which is 2 minus 3x squared. That is the derivative of 2x minus x cubed from first principles. All right, I'm going to stop here now for this in this video. I'm coming back with another video on first principles again, but this time I'm going to be dealing with a little bit more complex functions. For example, where I'm basically talking about rational and radical functions. All right, see you next time.